Now let's take a look at doing a double proportion, since I just finished discussing cardinal equivalence on the last AVI file. Here on the left we have the record, and we have a section corner that's lost, that's common to section 26, 27, 34, and 35, and we have the record bearings and distances for each segment. And notice that they all vary, they're not all just straight lines. And over here we have the field measured coordinates. And I do want to take a moment to mention this here, is that these are ground distances with an astronomic basis of bearings. If you're working in state plane coordinates, you cannot use the grid azimuths in the grid distances. If you do, you're mixing apples and oranges and you're going to put the corner in the wrong place. So you need to make sure that on your grid distances you use the combined scale factor and get the grid distances to ground distances. And for the grid azimuth, you need to use the convergence angle and the Laplace correction to get it from grid to geodetic and geodetic to astronomic, and then you're apples and apples at that point. A couple things to mention is, one is a double proportion is not a bearing-bearing intersection. It's not you intersect this line and intersect this line, and where they intersect is where the corner's at. And as I mentioned on my discussion on cardinal equivalence, that lengths of proportion lines are comparable only when reduced to their cardinal equivalence. So what I've done here is I've reduced the record to their cardinal equivalence, and I'm using a false number of significant digits because I'm trying to illustrate that even though this is very, very close to 40 whenever you take its cardinal equivalent in the record, it's very important that you go ahead and do so, because if this was more of a severe break, it would actually show up. And so here's, well, first I took the cardinal equivalent of this line, then this line, and then in north-south, and then I took the summation. So here's cosine of 0 degrees 2 minutes times 40, cosine of 0 degrees 1 minute times 40. Here's the cardinal equivalence, and here's the summation of the two. And next I took the cardinal equivalence of this line and then this line. And so south 89 degrees 56 minutes times 40.03, and sine 89 degrees 58 minutes times 39.94, and then I took the summation. Next I'm doing the proportioning. First I'm going to proportion in north-south direction. 39.999999323 is to 79.9999154, is to y as to 5177.52, and the 5177.52 is just the difference in the northings. So 10,177.52 minus 5,000, because remember I said on the discussional cardinal equivalence that just the difference in the northings is the cardinal equivalence in the north-south direction, and the difference in the eastings is the cardinal equivalent in the east-west direction. And that gives me y is equal to 2,588.76 feet. And then I do the east-west. 40 is to 0.0299729 as to 79 divided by 79.96996614 is to x is to 5,276.61, which is a difference in the field eastings. And that's x equals 2,641.27. Since I took the cardinal equivalence of this line, then I'm just going to add what I got for my y to this 5,000. And so it becomes y equals 5,000 plus 2,588.76. So the coordinate of my northing is 7,588.76 feet. And in my easting, since I took the cardinal equivalent of this point, of this line right here, I'm going to subtract what I got from my easting here. And so 7,642.99 minus 2,641.27 is 5,001.72 feet. So the coordinates of my lost section corner are 7,588.76 feet as the northing and 5,001.72 feet as the easting.